Algebra students, it's Mrs. Clear. We are going to run through the green worksheet you got in class the other day about converting forms. We will do about 4 of these together, and then there's 3 that you're going to do on your own on paper, and then when you're done, you're going to submit those answers in Schoology, okay? I'm going to try to talk you through how that's going to look as you submit it in Schoology as we go, okay? All right, so week 4 lesson, we're talking about converting polynomials. If I give you standard, could you give me factored? Could you give me vertex? If I give you factored, could you give me the other 2, and so on. So what you see I've done here on this worksheet, so I don't make a mistake, is I'm trying to show the ones that you're going to put in Schoology. So this one in Schoology, this one in Schoology, and this one. And how they're numbered is 1, 2, 3, 4, 5, and 6. Those are what you'll have to do on your own and submit. Okay, we're going to do the ones that aren't highlighted right now. So first, though, I want to make sure we remember what these forms are. I'm pretty sure you're solid on standard, probably even factored. It's vertex form. That's probably kind of new to us, right? And so in standard form, we are talking about ax squared plus bx plus c. So if I was identifying those components in standard form on the one that's up here, my a value would be 2. If we didn't see it there, it would be 1, right? An invisible 1. The b value is the coefficient of x, so it is -12. Let's say that -12. This is what you would be typing in this Schoology. And when we're identifying c, it's the standalone constant number. We're either adding or subtracting that, right? All right. So again, if you don't see a coefficient for x squared, it's going to be 1. And that's going to be true for the most part on this worksheet, except for this bottom one, all right? Now, factored form, you can see our examples up here. You see it written differently, and sometimes you see it as subtraction. We're going to just show it as addition for right now, but no, it can be subtraction, right? And so in identifying factored form, this factor would, the p-value here would be 3. -5 or -5, right? So when, again, you're typing this in, you'll have to type in +3 -5 to whatever you get as your factored form. And then vertex form, before I go there, our a value is technically sitting out here. Since we won't see it, it's because that a value is 1, right? Now, a value would be outside in vertex form of an x minus h, all of that squared, plus k. Now this minus and this plus will become important to us down the road. For now, we would just need to be identifying what is outside the parentheses, that a value, what's happening right here inside the parentheses. Are we adding or subtracting this number? What's happening outside? Are we adding or subtracting that number? Okay, so if I identify up here, must be 1 right here, I would be typing in +5 here, -16 out here. All right, the structure will be there in Schoology. You just have to put the numbers in, no letters, okay, no spaces. All right, so with that in mind, let's kind of pop back up here to the top. If you have scratch paper, you might want to use it. I'm going to see if I can squeeze it on here, at least for our first one, so you can have an example. So in factored form, what I'm saying is this is a product of 2 factors. This is the area, what was the length and the width, right? And we have done the box model, the area model, for factoring and multiplying, but more often what we include with it is this x method. So if I'm trying to do factored form, I figure out what a times c is, in this case 1 times 5. 5, put that up here in my box, and b value is 6. So numbers that add up to be 6 but multiply to be 5. So that one's pretty easy, right? And because I don't have an a value bigger than 1, I don't need to factor by grouping, or even maybe do that area model. I can just put these numbers that I found with the x method into my 2 factors here. So x minus 1, sorry, plus 1, and x plus, 5. Okay. Now, to get us to vertex form, there's not a connection really between factored and vertex. I have to go back to my polynomial, the standard polynomial, and complete the square. So when we get in vertex, we get it by completing, so if you could write this down to remind you, completing the square. So this is saying, if it's a perfect square trinomial, I can do this pretty easily, but this is not a perfect square trinomial because that 5 is not a perfect square, right? And so I would do the box method here, area method, to show I'm trying to create this perfect square where the x squared will go here. And the 5, since it's not so perfect, we're going to push aside, outside of our perfect square. You don't want to forget about it, but not for now. We're going to push it away. And I'm going to take my b value and divide it by 2, split it evenly along this outer and inner partial products, right? So dividing it by 2 would give me 3x and 3x. And all of that was done so that I could get x plus 3 and x plus 3 as my factors. Perfect square because the sides and factors are the same. And so, but how do I complete the square? By adding 9 right here. Now I'm going to subtract it also because I still want to maintain the original polynomial. It still needs to represent and be equivalent to this original, right? So technically all I've done is added 0. Why I do it is so I can express this part as a square, and then this part will be outside of that square to maintain, again, its original. So x plus 3 squared and negative 9 and negative 5. Sorry, that was supposed to be plus. I just saw it. It was a plus 5 that we kicked out. Negative 9 and 5 is minus 4. I just peeked back over there and went, wait a minute. Sorry about that. All right. So we've got our top example there where this was to get my factors. This was to complete the square. I'm probably going to show that work on some scratch paper because I need a little more space than that. All right, this one we're going to save. You're going to do that one in Schoology. You're going to do this one in Schoology. Remember, you're going to have to multiply this first, though, to get standard form, and then you're going to get vertex form. We have to get vertex form from standard form. We complete the square on standard form when A is 1. So how are we going to do this one? Well, let's do this one as an example. I'm really just going to multiply this, and I could do distributive property. I could do FOIL. I could do the area method. If I did FOIL, first, outer, inner, last, that just make sure I don't forget those 4 partial products. By saying the first are going to be x squared. The outer would be negative 5x or minus 5x. The inner would be a positive 3x or add 3x. And the last terms are 3 times negative 5. That's minus 15 or negative 15, right? And when I simplify my product here, I'm going to add these 2 together, right? And I'm going to write it down over here. X squared, the b value now comes back together to be negative 5 plus 3x or negative 2x. And then my minus 15 is out there. Okay, so what would you be typing in? This minus 2 and this minus 15. Now, let's take it from here and put it into vertex form by completing that square, meaning I want it to be a perfect little square of this side being the same. Okay, well, 15 is not going to make it a perfect square. So again, we're going to push it aside for now, the negative 15. We're going to take our b value of negative 2 and split it, okay, so that negative 1x is here and negative 1x is here. X squared, again, typically there. This just allowed me to find my factors, the sides that make it a square. And so I can express that as the perfect square. One side, add negative 1 times negative 1, and then subtract it so that I'm really just adding 0. The whole point was that I could express this one way and this the other. So if I slide that over, I'm going to say the square part is x minus 1 that I just completed. And this is what keeps it its original equality to either of these, right? Okay, so what would I be typing in again? Minus 1, minus 16. Hopefully we're catching the drift here, right? All right, this is one that we'll do together. So if we have vertex form like you're going to have to do, and I have to get the factored form in standard, we're going to put it to standard first because there's really not a lot we can do otherwise, right? Can't get it right into factored. So standard first, and then we'll factor it. So how do I get it to standard? I just have to do order of operations. I mean, that's really all I can do with this if I was going to convert it. And that says x minus 4 times x minus 4 minus 49. All right. Now, don't make the mistake of thinking it's distributing this exponent to, so we get x squared minus 4 squared, because that would completely ignore the fact that we have an outer and inner partial product, right? So instead, I am going to use my area model for multiplication, not for factoring now, right? And do x minus 4 here, x minus 4 here. Okay, that's perfect square. And if I multiply it out, I get an area of x squared minus 4x and plus 16. Okay. So this represents the same thing here, right? Of x minus 4 squared, right? But we still have this minus 49 over here, don't we? So if I express this, if I do it as a standard form, right? X squared minus 4, x minus 4, x plus 16. Don't forget, minus 49 is hanging out there, right? To get this into standard form, I'm going to combine some like terms, all right? So when I do that, make sure I'm on the right row here. X squared minus 8x, right? That's what these would add up to. And negative 16 and minus 49, minus 33. Okay, so I would type in minus 8 here, I would type in minus 33 here. Okay. Now that I have it in standard form, I can factor it. Okay. And I'll use that X method right here. A times C, negative 33. And B is negative 8, numbers that multiply to be 33, but add to be 8. And I could just start listing right here. There's not a lot for 33 though, right? I know it's going to be like 3 and 11. The issue is that since this is negative, one of these has to be negative, right? And so it turns out that this is the pair that will add up to be that negative 8. And all that means, remember, is I'm going to, this is how I'm going to split along my outer and inner diagonal of our area model. Okay. My factors, because I don't have an A value, are sitting right here, or 3 and negative 11. X positive 3 plus, that's what you would type in. And X minus 11 is what you would type in. Okay. All right, so the last one I wanted to do with you, you're not going to see one like it just because it's kind of something we would probably have emphasized a lot more if we've been with you in class more. And that is that the first step is always to see if there's a greatest common factor you can factor out, right? And so in our case right here, we do have a greatest common factor we can factor out. And if we did it, it would look like this, right? 2x squared minus 6x plus 5. Now that is one version of factored form, but it's not completely factored unless I check to see if there are factors in here. Is this factorable? All right. And so let me find another piece of paper. I'm going to see if I can find numbers that multiply to be 1 times 5 and add to be negative 6, right? This looks familiar. 1, 5, but it's got to be negative. So these are my factors given what's in the parentheses. It has an A value of 1. Okay. So 2 is still out there, right? But I factored further this part to be the x minus 1 and x minus 5. Right? If we were to try to complete the square on this, I would still have to do the same thing. I'd still have to use it from here. You cannot complete the square when you have an A value bigger than 1. Okay, so I'm going to write this x squared minus 6x plus 5 in brackets there because I want to redistribute that to later, all right? All right, so for completing the square, remember, we're going to kick out the 5 to the side. We're going to put the x squared here. We split this equally along the diagonal, so it's a perfect square. And figure out what I need to do to complete this, right? Well, my sides would be x minus 3. I would add 9, subtract it, right? Here's how I express the square part of it, x minus 3. And here's how I express that second part, the k value, negative 9 plus 5. Okay, so negative 9 to the side is minus 4. And the brackets should alert me to I'm not really done, I'm not simplifying. I have to redistribute my a value back to both of those terms because I pulled it out of both, right? So for vertex form then, it's going to be 2 times the square, 2 of those squares that are x minus 3, and 2 of these negative 4s, so minus 8. So if I were typing this in, I would have to type in an a value, which you aren't going to have to do, minus 3, minus 8. All right, I know that's a lot, so if you need any support, make sure you're kind of reaching out to your teacher. But yes, we do want to see this done by hand, right? And submitted in Schoology. Okay. All right, good luck to you. Take care.